Hello and welcome back. In this video we'll take a closer look on how we get the centroids and the clusters for the related damage classification. At the heart of this is we're using dbScan because we don't know the number of damage sites that we want to analyze or their exact shape, so dbScan is ideal for this. Remember, when we want to identify damage sites, we assume that any region below a certain threshold is a potential damage site candidate or an artifact. But it may so happen that we also have individual noise points because just 1 or 2 pixels happen to fall below the threshold, or that we have clusters that belong to the same damage type but are slightly different and they get found twice and we want to remove all of those. So this is what we do in this function. We have the centroid, so this is after cleanup everything that we want to return for the later analysis. So the cluster candidates are everything that is below a certain threshold, so everything that's dark in the picture. And we can see that sometimes the clusters have small holes in them. For example, individual pixels inside a damage region just happen to be slightly above or below the threshold. And this may confuse the clustering later on. So we can use the following method here to fill all of these holes. And then we have our cluster candidates, and we need to transform this as NumPy arrays and so on, so that we can then finally pass this to the dbScan algorithm that finds the clusters themselves. So we instantiate the instance of that class with the various parameters and fit the clusters and then take the labels. So dbScan works that for each unique cluster they assign a label to that point. But everything that is identified as noise gets a label -1. So this is what we take out here. So we have now the number of clusters. So this is the number of labels plus or minus everything taken out that is identified as noise. So we can count how many noise points we have. So for everything that is in the labels, if it's not a noise point greater than -1, because -1 in dbScan always signifies a noise point, then we have our cluster points if they are big enough. Right? So we also have the threshold that the damage site needs to exceed a certain size. So for example, we don't want to have damage site at just 1 or 2 pixels. And then, as we said before, we may have the case that we essentially find the same damage site twice just because it so happens that the various pixels are close together and we want to filter out those centroids. So we build a proximity tree, so we look at all the centroids that belong together, right? And then essentially build all the pairs for each cluster with each other cluster and say, is this cluster given a certain threshold the same as the cluster that I found before? You can imagine this more intuitively. You loop through all the clusters and take one cluster from the whole list and then look at all the other clusters and say, are they essentially the same? Do they overlap, or are they just very close to each other? And then if they have a certain threshold that they're essentially overlapping, you say, okay, well, this is essentially the same cluster. I only want to consider this once, right? And then you remove this other cluster from the list, and then finally you pass this on as to the calling function.